In this video, I'll be going through the multiplying and dividing polynomials unit test. So number 1 says, what is the area of the triangle shown to the right? So we're talking about area here, area of a triangle. So the first thing you want to think about is the formula for finding area of a triangle. Base times height divided by 2. Okay, so now we're going to plug the measurements that we have here into our formula. So our base, it shows us, is 2x. Our height, it shows us, is 6x. And then we're going to have to divide that all by 2. So let's multiply the monomials on top first. So 2 times 6 is 12. X times x is x squared. And we're not done yet because it's not a rectangle, so it's not just base times height. We still have to divide that by 2. So 12 divided by 2 is 6. X squared divided by no variable, so there's nothing to cancel with it, so it just stays the same. So 6x squared is our answer. Number 2, it wants us to circle the multiplication statement shown by the algebra tiles. So let's look at what we have here. We've got 2 positive x's right here, so that's positive 2x. We've got 2 negative x's here. And inside, each of these is a negative x squared. And we've got 4 of them, so negative 4x squared. So that's what we need to look for in our multiplication. So right away, I can eliminate this one because it's got a positive times a positive. That's not true. This is a positive times a negative. So that's out. And this one, because it shows negative times negative, that's not true. And also this one, look at that, positive times positive, not true. Okay, we've got positive and negative, opposites. So that leaves us with A. Without even looking at the answer, it leaves us with A. I think I need to change pens here. Okay, so now numerical response number 1. The simplified form of the expression, negative 2x times negative 3x minus 5 is, okay, so we just have to solve that out. So I'm just going to use distributive property, but you could also do an area diagram, or you could do algebra tiles, any strategy you like. And if you wanted to look up one of my previous videos about the different strategies to do monomial times polynomial, that would be a great idea. So distributive property. So first I need to identify the monomial. One term, negative 2x, okay, times it by the first term of the binomial. So a negative times a negative, match, so that's going to make a positive. 2 times 3 is 6, x times x, x squared. Now next distribution. So monomial times the second term, negative times a negative, positive. 2 times 5, 10, x times nothing. Okay, there's nothing for it to combine with. There's no other exponents to add, so it just stays the same as x. So that's my final answer then. Positive 6x squared plus 10x. Okay, number 3, volume. Volume of a rectangular prism. Again, we need to start by thinking of the formula. We've got length times width times height. I had to think about that for a minute. But basically with volume, you just multiply all 3 dimensions that they give you together. So the dimensions of the flat surface and then multiplied with the dimension of the height. So my length right here, 6x, times my width right here, 2x, times my height right here, 2x. Okay? And we're just going to take it one at a time. So we'll deal with this 6x times 2x first. So 6 times 2 is 12. X times x is x squared. Now we can multiply that by our 2x. So 12 times 2, 24. X squared times x, okay, we'll just add the exponents. 2 plus 1, that gives us x exponent 3. So there's our answer, B. Number 4. Okay, this time, this is very similar to number 2, but this time we're looking at an area model instead of algebra tiles. But we just need to choose the multiplication statement that this is representing. So here's our monomial, 3x. Okay, They all have that as a monomial, so I can't eliminate anything yet. And then here's my binomial, 4x. And because there's no negative sign, I know that's positive. So 4x plus 2. So that eliminates this one, because this is showing 4x minus 2. There's no negative sign, so that's out. Same thing here, no negative sign, that's out. Okay, these two, A and C, well, they have the same question, so I'm going to have to figure out the answer here. So let's find the area of this section first. So length times width, 4x times 3x. 4 times 3 is 12. X times x, x squared. Now this area, okay, length times width again, 3x times 2. So 3 times 2 is 6. X times no other variable just stays the same. Okay, and because it's not a negative, we know it's a positive. So 12x plus 6. Oh, so look, this is not even close. So that's gone. Definitely A. 12x squared plus 6x, just like we got. Number 5, they tell us to expand using distributive property. Same thing we did up here. That was distributive property. So we identify the monomial, which is one term, so that's that one. We're going to multiply it by the first term of the binomial and then by the second term. So first term first. Negative times a positive, mismatch. 3 times 4, 12. Y times y, y squared. Second distribution. Negative times a positive, mismatch. Negative. 3 times 1, 3. Y times no variable. Okay, nothing's doubling up, it just stays the same. Okay, so that gives me B as an answer. Okay, number 6. Determine the unknown dimension of the rectangle shown below. Okay, so we've got a missing factor here. We know that normally to find the area of a shape, we do length times width. That gives us the area of a rectangle. Okay, but this time I have the area. What I'm missing is one of my factors. I'm missing my length here. Okay, so we have to think opposite of multiplication. What is it? Division. So we're going to take our area and we're going to divide it by the factor that we do have to solve for the factor that we don't. So anytime you have a missing dimension, a missing factor, that's always division. Okay, just like with the algebra tiles, when we model it out, we have the answer drawn in the inside, we have a factor on the outside, and we're solving for one of the missing ones. Okay, exact same idea here. It's not algebra tiles, but it's the same thing. Okay, so binomial divided by monomial. First term divided by the monomial. 16 divided by 4. I'm going to run out of space here. Shoot, I guess I'll go underneath. 16 divided by 4 gives me 4. X squared divided by x. Well, this 1x is going to cancel with one of these x's and leave me with just x exponent 1, which I can just write as x. Okay, now second term divided by the monomial. Positive 4 divided by positive 4. Okay, so it's going to be a positive. 4 divided by 4, 1. X divided by x. Well, both of those, this 1x down here cancels with this 1x here. So we're left with no x's. So that's what it looks like, 4x plus 1, which is C. Okay, I think I saw that a lot of people chose B, just 4x. But that really doesn't make sense because we just treat the numbers like normal numbers. It's only the variables that cancel out. And 4 divided by 4 is not 0. 4 divided by 4 is 1. So we still have to have that 1 there. So this is not correct. Okay. So number 7, again, distributive property. So we're going to have to times it by the first term, times it by the second term. The tricky thing here is that our monomial is a fraction. So when we go to times it by these whole numbers, it can get confusing. But to deal with that, all we need to do is turn these into fractions. So we'll keep this the way it is, 3 over 4x times, okay, this 8. You can change any whole into a fraction by putting it over 1. So it becomes 8 over 1x plus 4 over 1. Okay, so same steps for distributive property. Times it by the first term. So before I do that, I always like to cross cancel first. It just keeps my fraction lower. Doesn't mean that it's impossible to do it without cross canceling. It just keeps the fraction more manageable. So this way, anything, no, because 1 is already as low as we can go. So we know for sure we can't cancel anything that way. But what about between 4 and 8? Is there anything that they're both divisible by? Yeah, they're both divisible by 4. 4 divided by 4 gives me 1. 8 divided by 4 gives me 2. So now let's go ahead and multiply. So top times top, 3 times 2 equals 6. Bottom times bottom, 1 times 1 equals 1. Letter times letter, x times x, x squared. So that takes care of the first distribution. On to the second one. Again, let's cross cancel first. So definitely nothing between the 1 and 3. 1's already as low as we can go. But between 4 and 4, anything they're both divisible by? Yeah, of course, they're both divisible by 4. So 4 divided by 4 is 1. 4 divided by 4 is 1. Now let's multiply. 3 times 1, both positive, equals a positive. And 1 times 1 is 1. X times nothing just stays as x. So now the only other thing is when we have fractions both over 1, we can simplify by just taking that denominator of 1 away. So then that leaves us with C as our answer. Okay, numeric response number 2. What is the exponent of the final product? We've got monomial times monomial. Okay, so monomial times monomial, we just deal with the numbers first. 4 times 2 equals 8. And then the variables, x squared times x. Okay, add the exponents according to exponent laws, so it becomes x exponent 3. So what is our exponent? It's 3. Our exponent is 3. Okay, number 8. Leah simplified the expression 21x squared plus 14x divided by 7x. Which of the following classifications describes the quotient? Quotient just simply means the answer to this division thing. So when she actually solves this out, what is my quotient going to be? Is it going to be a monomial, a trinomial, binomial, or a constant? Okay, well, even without solving this, I see that it's already a binomial. So unless everything's going to cancel out with the second term here, it's still going to be a binomial. And the only way that everything could cancel out with the bottom and the second term is if there was just a plus x and divided by x. That's the only way. So even without solving anything, I can actually already see that it's going to be a binomial. But just to show you, 21 divided by 7, 3, x squared divided by x. This 1x will cancel with one of these x's and leave me with 1. 14, positive 14 divided by positive 7, positive 2. And x divided by x, gone. They cancel out, so nothing. Still a binomial, still 2 terms. Okay, so even if you had to solve it out, you'll see it's a binomial. Okay, numerical response number 3. Write a simplified expression for the perimeter. Okay, it saw a ton of people solving this for area. But perimeter is not the same thing as area. Perimeter is the distance all the way around the outside of the rectangle. Okay, so we have to figure out what the total is here. So you could either add each one up separately, 5y plus 7y minus 4 plus 5y plus 7y minus 4, or we can use a little multiplication as a shortcut. So we've got 2 widths, so we can go 2 times our width, plus we've got 2 lengths, so we can go 2 times our length. Okay, so multiply first and then we'll add. Bedmass, right? Proper order of operations. 2 times 5 equals 10. Y times nothing. Nothing for it to combine with, so it just stays as y. Plus, I'm not dealing with that yet. That'll come later. Okay, this one, monomial times binomial, distributive property. So we're going to times it by the first term first. 2 times 7, 14. Y times no variable stays the same. 2 times negative 4, mismatch, so that's negative 8. And there's no variables here, so that's it. But I'm not quite done because I still need to add. And when I add or subtract, I have to look for like terms. Remember, you can only add or subtract like terms. So my first term, 10y. Is there a like term? Yes, there is. Positive 14y. Both of them are y's with an exponent of 1. Those are like terms. That means we can combine them. We can add them. 10 plus 14, 24. They're still y's. Okay, I saw lots of people forgetting what we did last unit, and they were adding the variable, so then they said, oh, there's 2y, so this becomes a 2. No, 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 no. The only time we add the exponents on the variables is when we're multiplying. Okay, we don't do anything to these variables when we're adding. That's why we have to group them in like terms. Because I have 10 y's plus 14 more y's gives me 24 y's total. Okay, so and the only time that I ever subtract exponents on the variable is when I'm dividing. Okay, I don't subtract exponents on the variable if I'm subtracting. Okay, adding and subtracting, we don't mess with the variables at all. Oops, I'm not done yet. I still have this constant here, negative 8, no like terms, so it stays as it is. We cannot combine these. These are not like terms, so this is our final answer. Okay, so this next one, the product of negative 3.7x times 5.1y in simplified form. Monomial times monomial. Okay, I don't even need distributive property here. I'm just going to go number times number. Well, first of all, it's a negative times a positive, mismatch. So I know it's going to be negative. Now 3.7 times 5.1. 18.87. X times y. xy. That's it. That's my answer. Negative 18.87 xy. Okay, this one, the quotient of 10x squared divided by 4x in simplified decimal form. Okay, so again, it's just monomial by monomial. Okay, so 10 divided by 4. I've got a good mental math strategy for that. Okay, dividing by 4 is just splitting something in half twice. So 10 divided by 2 gives me 5. And let's half it again. 5 divided by 2 gives me 2.5. And both are positive, so it is going to give me a positive integer. Now we've got x squared divided by x. So we subtract the exponents when we're dividing. So that leaves us with just an x. So 2.5x. Okay, written response now. This one is this exact question with these exact numbers is in one of my previous videos. So if you had watched, this would have basically been a freebie for you. But I'll go through it again real quick here. So you're decorating a bulletin board in your classroom with pictures of your classmates. Each picture covers an area of 4x centimeters squared. The area of the board is 4x squared plus 16x centimeters squared. Write an expression to represent how many pictures are required to cover the board. So we have this big board and we have all these little pictures. And what we're trying to do is we're trying to figure out, basically what we're doing is splitting this big board up into the size of the little pictures, trying to figure out how many of these can fit. Okay, as soon as you're taking something big and splitting it up into small sections, well, another word for splitting up is dividing up. It's division. So we'll take the area of the big board, 4x squared plus 16x, and you'll notice I'm just going to leave off the units for now. That's not part of the algebra. I can always bring them back later. I don't want to get myself confused. Divided by the area of the picture, 4x. So we've got binomial divided by monomial. Okay, first term divided by monomial. 4 divided by 4, 1. X squared divided by x. This 1x will cancel with one of these x's up here, leaving me with just 1. Now, second term, positive 16 divided by positive 4. That gives me positive 4. X divided by x. 1x down here, 1x up here, leaves me with no more x's. So this is my answer, but I need to simplify it. Best answer will be in simplified form. If you have a coefficient of 1, you don't actually need to include it. So x plus 4 would be my final answer. And to bring back my units, well, what it's asking about is how many pictures. So this is x plus 4 pictures. That's what we're talking about here. So we don't even actually need to bring back centimeters because that's not what we're talking about. Okay, number 2 says 2 pieces of cloth are cut. Determine a simplified expression for the total area of both pieces of cloth. So first thing we need to do is figure out the area of each of these little cloths. So area of a rectangle, what's the formula for that? Length times width. Length times width. The length on this first checker cloth, 3c. The width, c plus 1. Here, the length, c plus 3. The width, 2c. Okay, so multiply them out now, length times width, right? Distributive property. So identify the monomial, that's this one, times it by the first term. So 3c times, this is basically 1c, so 3 times 1 is 3, c times c is c squared. Second distribution, positive 3 times positive 1 gives me positive 3. C times no variable, well, there's nothing to double up or anything, so it just stays as c. Second area, identify my monomial. Okay, so this time it's here. Okay, first distribution. 2c times 1c. 2 times 1, 2. C times c, c squared. Second distribution. 2 times 3, positive and positive, so that's how I know it's a positive. 6. C times no variable stays as c. Okay, but I'm not done yet. And the reason why is because it asks for the total area of both pieces. As soon as you see the word total, you know we're talking about addition. So I have the area of the checker cloth, I have the area, I guess they're both kind of checker. I have the area of both of them, but I need the total. So that means I need to add these two up. I'm running out of space. So 3c squared plus 3c plus 2c squared plus 6c. Okay, I'm just adding both of those binomials together. Okay, now when it comes to adding polynomials, I need to look at like terms. So 3c squared, what is that alike to? What term is that alike with? 2c squared. Okay, both of them are c's squared. That's why they're like terms. And we're not going to mess around with the variables at all, but we can add the coefficients. 3, positive 3, combined with positive 2, both positive. So that comes out to positive 5, and they're still c squared. Okay, that doesn't change. That's why we can only combine like terms. It's because they're 3c squared combined with 2 more c squared just gives me 5c squared. Okay, now on to this one. Positive 3c. That's alike with positive 6c. So positive 3, positive 6. Combined gives me positive 9. 6 and 3 is 9. And the c just stays the same. That's our like term. Altogether, if we have 3 c's over here and we have 6 c's over here, bring them together, we're going to have 9 c's. Nothing happens with the variable. They're still c's. So that's the total area there. And I'm just looking if I need units. It wasn't given to me with units, so that's it. I could say units squared because it's unknown units. So 5c plus 9c units squared. Okay, last one. What is the total surface area of this rectangular prism? Okay, I think some people overcomplicated this a bit. You know how to find surface area, you know how to multiply polynomials, and you know how to add polynomials. That's the only three things you need to know how to do here. So start by using what we know about finding surface area. Okay, breaking it down into our three sets of sides, meaning front, back, left, right, top, bottom. So let's look at the front first. Okay, it's just a rectangle. Area of a rectangle, length times width. What's the length? 3a. What's the width? 2a. Okay, monomial times monomial. 3 times 2 is 6. A times a squared. Okay, so that takes care of my front, but I also have a back. But remember, the back matches the front. So what can I do? I can just double this. Okay, times it by 2. 6 times 2 gives me 12. A squared times no variables stays as a squared. Okay, so that takes care of front and back. Okay, left and right now. So over here, again, it's just a rectangle. Length times width. A times 2a. Monomial multiplication again. Okay, no coefficient. Remember, it's automatically a 1. 2 times 1 is 2. A times a squared. So that takes care of the right side. But remember, I've also got this left side over here. But it's the same. So again, let's just times it by 2. 2 times 2 is 4. A squared times no variable remains as a squared. So now I've accounted for the left as well. Finally, top and bottom. Let's look at the top. Again, just a rectangle. Length times width. The length, 3a. The width, a. Okay. Monomial times monomial. Okay, if there's no coefficient, it's a 1. 3 times 1 is 3. A times a squared. That takes care of the top, but I also have the matching bottom. So again, let's times that by 2. 3 times 2 is 6. A squared times no variable just stays as a squared. So I've accounted for my back as well. So I've got every view covered, every area taken care of. So I've got all my surface area. The only thing I have left to do is to total them up. Again, there's that word total. Anytime you see total, it means you're going to be adding. So let's add these all up to find the total. 12a squared plus 4a squared plus 6a squared. So to be able to add polynomials, I need to group like terms. But look at this. These are all like terms. That's convenient. Okay, they're all a squareds. So that means that they can actually all be added together. So 12 plus 4, 16. 16 plus 6, 22. And when we're adding, we don't mess around with the variables. We don't change anything. They're still all a squareds. So some people got to this, but then they're adding the exponent. No, no, no. Okay, only time you add the exponent is if you're multiplying. If you're adding, the exponent does not change. It has to stay the same. So 22a squared is our total surface area. And they don't give us units here, so we could just write units squared because it is area. Area is always units squared. So 22a squared units squared would be our final answer. Okay, well, I hope that was helpful. Thanks for watching, guys. Have a good night.